Now, what the pragmatists, though, are interested in is the status of logic, right, as a whole. And while everybody is very impressed with what has been achieved by deductive logic, there is still an important point about the relationship between deductive logic and inductive logic. We can focus on the patterns here, but notice that all of the examples we're using here in deductive argument involve these generalizations. All of the L's are G, all of the H's are M's, all of the A's are B. Where do we get those generalizations from in the first place? Well, of course, I just made them up, right? But in reality, when we're reasoning about reality in the real world, the deductive, or rather the premises that we want to use in deductive reasoning, all of those generalities involve some sort of initial observations that led us to certain kinds of general conclusions, and that is where inductive reasoning comes in. And inductive reasoning, again, on one classical account of inductive reasoning, is to start with particular observations or statements of particular fact, and when we collect a certain number of them, then we are in a position cognitively to make a generalization to a whole group of things. So if we said, for example, all humans are mortal, where did we get that generalizations from? Well, presumably back in the past, at some point, people are observing humans, human dies. This other human dies, this other human dies, seems to happen to all of the humans in that person's acquaintance, and then somebody at some point gets the idea, well, therefore, it must be true of all human beings. And then we learn that partly based on our own experience, but also partly from the reports of everybody else's particular observations over the course of history and so on. Example, I always think at this point here, not relying on other people's historical say-so. I remember when I started graduate school, it was a place in the world that had a lot of cardinals, which was a relatively new phenomenon for me since I grew up in Canada, and seeing cardinals is a relatively rare phenomenon there. So I found myself fascinated for a couple of months when I saw a whole bunch of cardinals. But outside of my apartment in graduate school, I had a nice big window that looked out the back, and there were some bushes back there. I noticed that there was a male cardinal that came in, so I was observing it, and then another male cardinal came and landed on the same bush, and instantly the first male cardinal attacked it. They got into a bit of a tussle, and one of the cardinals flew off. And then I started to notice over the next week or so that this was a regular phenomenon. Every time there was a male cardinal somewhere, if another male cardinal came within, I believe, anything like 12 feet or 15 feet or so, it would be chased off by the first cardinal that had been there, or it would succeed in driving off the cardinal that was already there. So I saw this maybe a dozen times or so, but before the dozen times had occurred, I'd already kind of come up with a generalization and say, oh, these are male cardinals. All male cardinals are territorial in the spring. And we do that all of the time. That's just very base level scientific reasoning. So I might be saying, something like this. This cardinal is territorial. That's a report of my first observation. Then it happens again. So then I say this cardinal, we'll call it C1, is also territorial. And then I see it again. Here's another cardinal. It also, is territorial. And that goes on. I collect all of these observations. But then at a certain point, I come to a generalizations that all cardinals are territorial. And I feel quite comfortable in that observation. Not so fast, Say the pragmatists and any number of people prior to the pragmatists who have been studying induction as a process of reasoning here. They'll say, if you want to figure out whether this is true or not, we have to pay attention to how much evidence we actually have in support of this particular conclusion here. And what they will say is, look, you might feel quite certain, quite comfortable and so forth about reaching this conclusion on the basis of a few or several observations here, but that speaks more to you rather than the actual logical truth of the situation here. Because consider the scope of this conclusion proposition here. All cardinals are territorial. That's a great, huge, whopping generalization about all of the cardinals that are out there. How many cardinals are there out there? Well, there's dozens and dozens. No, actually there's millions and millions. And it's not just the cardinals that exist now. It's the cardinals that existed 5 years ago, the cardinals that existed a century ago. All of those are covered by this proposition here. All of the cardinals that don't yet exist but will come into existence here. We're talking about a potentially infinite number, of particular entities here. But up here in the numerator, we have a very finite number, right, of observations, and on the basis of that, we're generating something that's a potentially infinite number of entities in the class. Now, this is a cheap way of doing this here, but if you actually think of the probabilities of things, how do you calculate the probabilities? Well, you take the number of instances that are possible to you, or in this case, the number of observations that you've actually undergone. That's going to be some low finite number here, and then you divide that into the denominator, but anytime you divide by infinity, I believe, you get pretty much zero, right, probability. By analogy, if you want to figure out what's the probability on a six-sided dice, or die rather, that you're going to get a 3, say, well, you say the die has 6 sides and you're going to roll it once, so you have 1 chance in 6 in this particular case. So the number of possibilities available to you, or given the total number of possibilities here, then you have a 1/6 probability, whatever that works out. In this case here, we're dealing with something that's approaching infinity, so the actual probability is going to then be approaching 0. So the point is, obviously all of this is very controversial and stated very hastily, but the point is, from a finite number of observations, and we're always dealing with a finite number of observations, those who are more skeptical about induction will say we have to be very tentative in reaching great big generalizations over here. So what we should say is not that all C's are T in this case, but probably. Right, and then again, we've got a probabilistic type of qualifier here. And if it's only been a couple of observations, then I might even use weaker language. Well, it's a possibility, right? Or it's a tentative hypothesis, right? And so on. And the more observations I have, the more comfortable I'm going to be. But even if I get up to hundreds or thousands or even tens of thousands of observations, that still is a relatively small number relative to the overall number of things that I'm trying to generalize to. So I have to be tentative in my conclusions, I have to be probabilistic, and I have to recognize that, well, I don't know, maybe I haven't checked all of the cardinals in Asia, if there are cardinals in Asia. I haven't checked the cardinals in Idaho, right, so to speak. I've only checked the cardinals in the Midwest, so I need to get a much more diverse sample and so forth. And until I've done all of that kind of work, and I'm never actually going to get around to doing all of that work, nobody is, my hypotheses have to be subject to change. All right, putting all of that together, what we have from the pragmatist position is a taking very seriously skeptical objections to the power of reason. Now, we're not going to throw reason out entirely. We're not going to throw observation out entirely, right, as pragmatists. We still think that observation and reasoning and science is the best thing going, but we can't be as excited about it, and we can't be, from their perspective, as naive about it as they would claim the realists have been about the power of scientific method.